Hello everyone. In this video we are going to see what is isothermal evaporation, and we will solve some problems on isothermal evaporation of water into air. Okay. So first thing, what is isothermal evaporation? If I keep water or coffee in a cup, by times goes on, the water in the cup will reduces because of the water is evaporated into the air because of the temperature difference and more concentration difference. Okay. So that is called as isothermal evaporation. Now I am going to take a cup or a test tube like that, right? So this is my cup or a test tube. In this partially the water is filled, right? This is the cup. Partially the water is filled. Now this value from the bottom to this value is known as x1. From the bottom to the top of the cup, that is the top of the chamber, is known as x2. Now this is known as x2 minus x1. Okay, here the air is flowing in this direction. Because of the air flow movement, the water inside the cup will start to evaporate and mixed with the air. So here there will be water vapor, right? So water here is converted into water vapor and it is stored here. By means of the air flowing in this direction, the water vapor is taken into the atmosphere, right? So here it is MA, water vapor diffusion rate is MA, molar flux, right? So from the Fick's law we can find out the equation for this. So molar flux MA divided by area is equal to DAB divided by GT into P divided by x2 minus x1 ln of PA2 divided by PA1, right? So this formula also available in the data book itself, right? Or this can be rewritten like this. The other form of this equation is DAB divided by GT P divided by x2 minus x1 into ln of P minus PW2 divided by P minus PW1. By these two formula we can solve the problem, right? So now we will solve first problem. Here this is the first problem. A pan of 40 mm deep is filled with water to a level of 20 mm. Now I am just representing like this. Up to here the water is filled, so it is 20 mm and the total height is 40 mm, and here it is also 20 mm. So 40 minus 20. Okay, this is a representation of the diagram, and it is exposed to dry air at 30 degrees Celsius. Okay, so this is the diameter of the flask or tube or test tube, whatever it is. Here air is at 30 degrees Celsius and mass diffusivity is, that is DAB, is 0.25 into 10 to the power minus 4 meter square per seconds. If it is given in terms of meter square per seconds, then it will be the value of DAB, right? And here calculate the time required for all the water to evaporate. The total amount of water has to be evaporated. You have to find out the time required to evaporate the complete water. So here I am writing the given data. x2 is equal to 40 mm, x1 equal to 20 mm, which is equal to 0.04 meter. Here it is 0.02 meter, and the diffusion coefficient as already written here. Okay. Now from the data book, MA divided by A is equal to DAB divided by GT into P divided by x2 minus x1 ln P minus PW2 divided by P minus PW1. Okay, I am going to use this formula only. Now in this formula, PW2 comma PW1 are the water vapor pressure at that temperature, right? That value has to be taken from the data book, right? So total pressure P equal to 1 bar, which is equal to 1.013 into 10 to the power 5 Newton per meter squared, okay, at 30 degrees Celsius from steam table, page number 2, PW1 water vapor pressure is equal to 0.04242 into 10 to the power 5 Newton per meter squared, right? So this is PW1, and PW2 is nothing but at the top of the pan the dry atmospheric pressure, water pressure. So here there will be pressure, water, air will be no. So here it will be air, here it will be water vapor. PW1 is nothing but partial pressure of the water vapor present here, and PW2 is partial pressure of the water vapor present here, right? So here I have taken at 30 degrees Celsius from the steam table. Here in the problem it is given that it is dry saturated atmospheric air. Since dry saturated atmospheric air, there will be no water vapor present in that dry saturated air. So PW2 equal to 0, right? Just write here at top of pan dry atmospheric air is present. So PW2 equal to 0. Now m dot A divided by A is equal to 0.25 into 10 to the power minus 4 divided by G value 8314 into temperature 303 into pressure is 1.013 into 10 to the power 5 divided by x2 minus x1 is 20 mm. So it is 0.02 into ln of 1.013 into 10 to the power 5 minus PW2 is 0 divided by 1.013 into 10 to the power 5 minus PW1 is 0.04242 into 10 to the power 5. Have to use the calculator carefully in order to find the correct answer. So m dot A divided by A will become 2.15 into 10 to the power minus 6 kilogram mole per second meter squared, right? So now you have to find out the mass flow rate of water vapor. Mass transfer rate or mass flow rate, whatever it is. Mass flow rate is molar rate of water vapor into molecular weight of the steam. Okay, the molecular weight of the steam can be taken from the HMT data book. It is 18.016. Molar rate we have find out 2.15 into 10 to the power minus 6. So the final answer will be 3.87 into 10 to the power minus 5 kilogram per second meter squared, right? Okay, in the problem you are not asked to find out the mass flow rate. You are asked to find out the amount of water to be evaporated and the time required to evaporate that amount of water. So amount of, first thing, amount of water to be evaporated is equal to volume into density rho. So the volume is, it is 20 mm filled, no, so 0.02 into dense into 1 into density is 1000. So here I am putting as 1 because it is a rectangular container. I am considering that the rectangular container is 1 by 1, right? So it is not given in the problem. I am just assuming that the rectangular container size, that is the cross sectional area, is 1 cross 1. So I am putting 1 meter squared area, cross sectional area, and multiplying it with the height of the water filled so that I can get the volume into density. You will get the amount of water to be evaporated. 20 kilogram of water will be evaporated per meter squared area of the rectangular tank, right? So now you have to find out the time required. time required equal to the total amount of water to be evaporated 20 kg divided by mass transfer rate of water vapor, that is 3.87 into 10 to the power 5. We have find out now that value has to be substituted here. It is 10 to the power minus 5. So the final answer will be T equal to 516.79 into 10 to the power 3 seconds. Okay, the total amount of water will evaporate at this time. So now go to the second problem. Here an open pan of 20 centimeter in diameter. So it is a circular pan. So it is having 20 centimeter diameter. So write D equal to 20 centimeter, which is equal to 0.2 meter, right? So and 8 centimeter deep, it contains water at 25 degrees Celsius. Okay, so the depth x2 minus x1 equal to 8 centimeter, which is equal to 0.8 meter. 0.08 meter. Okay, 8 centimeter contains water at 25 degrees Celsius. So T equal to 298 Kelvin and it is exposed to dry atmospheric air. If rate of diffusion of water vapor is 8.54, so mass rate equal to 8.54 into 10 to the power minus 4 kilogram per hour. You can divide this value by 3600 to get kilogram per seconds. So this is 2.37 into 10 to the power minus 7 kilogram per seconds. Okay, then estimate the diffusion coefficient of the water. It is given in the reverse direction, right? So first thing, you know the mass flow rate and you have to know the mass molar rate, that is MA divided by A. You know the formula MA divided by A. One second. You have to use this formula, right? From this formula you have to find out DAB value. To know this value, you have to know M dot A divided by A. Now you know the value of mass rate. From the mass rate, you can find out the molar rate. So mass rate is equal to molar rate into molecular weight M. From this, you can find out molar rate. M dot A divided by A is equal to 2.37 into 10 to the power minus 7 divided by 18.016, right? Molecular rate of steam 18.016. So now area equal to pi by 4 d squared, it is 0.0314 meter squared and G value you know, pressure is atmospheric pressure and the only thing you have to know is PW1 and PW2 at the given temperature 25 degrees Celsius. From steam table you know that PW1 equal to 0.03166 into 10 to the power 5 Newton per meter squared. In the outside it is dry saturated air, so PW2 equal to 0. Okay, now substitute all the values in this formula. M dot A equal to DAB divided by G into T into P divided by x2 minus x1 into ln of P minus PW2 divided by P minus PW1. Okay, substitute all the values in this formula. You can find out diffusion coefficient DAB as 2.58 into 10 to the power minus 5 meter squared per seconds. Okay, this will be your final answer. Okay, here I am giving you two problems for practice. In the first problem, estimate the diffusion rate of water vapor from the bottom of a test tube. So it is a test tube, so you can assume that isothermal evaporation. The test tube diameter is 1.5 centimeter and it is 15 centimeter long into dry air at 25 degrees Celsius. So take DAB equal to 0.256 centimeter squared per second. So you have to convert this into meter squared per second. I think there will be no doubt to solve this problem because it is dry atmospheric air. So you can assume that PW2 equal to 0. You are asked to find out the diffusion rate of the water vapor from bottom. So diffusion rate is nothing but mass transfer rate. So by using the formula molar transfer rate, you can find out that, and by using mass flow rate formula, you can find out the mass flow rate, right? So similar to the last two problems, you can solve this problem. And the next interesting problem is an open pan of 150 mm diameter and 75 mm deep contains water at 25 degrees Celsius, right? So these things are all known from the last two problems, right? And it is exposed to atmospheric air at 25 degrees Celsius and 50 percentage RH, right? So relative humidity value is given in this problem. So in last three problems, it is given that it is dry saturated air, so that you took PW2, that is the pressure of water vapor, as 0. But here the air at the atmosphere has contained some amount of water vapor with that, so that value is given as 50 percentage relative humidity. You know that relative humidity is the amount of water vapor present in the atmospheric air, right? So now PW2 value becomes PW of dry air into 0.5. This is the PW2 value. So you have to, from the steam table, you have to take at 25 degrees Celsius, take the dry air water vapor PW of dry air into 0.5, which gives the PW2 value, right? So you know that PW1 is known as at given temperature pressure of water vapor. From the steam table, just take water vapor properties, but for to find out PW2, you have to take the properties, that is the pressure of dry air at 25 degrees Celsius, and multiply that pressure of dry air at 25 degrees Celsius into 0.5, that is 0.5 is nothing but your relative humidity value. Okay, thank you all.